Okay, so we're going to do a little work with tables and a graph and how they work with functions. Here we have a table, and it's talking about pets, a type of pet, and a memory span in hours, like how long they can remember something. I'm not really sure how they test that, but anyway, I'd always heard like a goldfish had a memory of like 5 seconds. I think your book says 3 seconds, but apparently that's a myth, an urban legend or something, because it says here that a goldfish, apparently they tested the goldfish, and they have a memory span of 200 or 2,160 hours. So I'm thinking that's how long they can remember something. It was a long time. The betta fish, man, they have a really long memory, I guess. But a puppy, not so much. Not even an hour, right? So 0.008 hours, or 8 thousandths of an hour. Okay, a cat can remember something for 16 hours. I don't know. This is just some information about how we read the table. This is like a vertical table. You have your input here and your output here. Now, you can talk the other way and say, hey, which animal has a memory span of 0.083 hours? And you look on the table and you say, oh, it's an adult dog. Okay, so it's just kind of like reading a table. Now we want to put that, though, with our notation. Now, in this example, 3.1, we've got a horizontal table. So it says evaluate G of 3. N is the input, and then this is the output, G of n. Now we know that from our function notation. So it says evaluate G of 3. So in this case, n is 3. So you go on your table, you go to n, you find where it's 3, and then you read the output. So G of 3 equals 7. Okay? All right. So not too bad once we understand the notation and how tables work. This one says solve, which is kind of an interesting word to use, but they want to know what n is. What's the input if the output is 6? So they're giving you the output, the G of n, and they want to know the input. So it's like you're going the other way. So you're going to G of n, where is there a 6? Well, there's a 6, and there's a 6. It's there twice, right? Okay, but that's okay in a function. You can have the output be the same for different inputs. Okay, but what are the inputs then? Well, n is 2. That's one of them. Or n is 4. You write it like that, or you could just say 2, 4, something like that. Okay, so that, in this case, they were giving us the output, and we had to find the input. So sometimes that's confusing to students. It's a little easier to go the other way. Okay, now they don't give us a table, but they actually give us a graph. And so we're going to read the graph similarly. This will be our x along the x-axis. So we know that. There's the x-axis. And then the y-axis is f of x. So in this case, for a, we're saying x equals 2. So we're going to go over to 2. And then we're going to read where it hits the graph. What's the output? So f of 2 equals 1. So we're getting that by reading across to the y output there. Okay? Now try not to confuse that with the other part of the graph, but this point right here that I have a big black dot on, that point is 2, 1. So input x, output f of x. Okay? Now we're going to do the graph, same graph, but we're going to do a solving thing where we're going the other way. So now we want an output of 4, and we want to know what's x. What's the input? Okay, so if f of x is 4, you got to go on the f of x axis. So go to 4, there's 4, and then you're going to read to the graph. So one way we can go, we're going to get a point there, and the other way we get a point there, right? Okay, so what are the coordinates for those 2 points? Well, this first one, you got to read down now on the x-axis. It's -1, 4. And then the other point, read down. That point right there is 3, 4. So what is x if the output's 4? What's the input if the output is 4? Well, x could be -1, or it could be, 3, not 4, 3. You don't always get 2 inputs when you have problems like that. It just happens that on our 2 examples they did. Okay, so that's a little bit about tables and graphs. Oops.